Hey everybody, Mr. Reeves back with you yet again, and we're going to be going through the latest IXL skills. We're actually doing a review of proportional relationships. We're going to be doing K8 through K11. All right, here we go. So K8 says complete a table and a graph of a proportional relationship. So they gave us the equation y is equal to x. All right, so y is equal to x. So if x is 4, y is 4. If x is 6, y is 6. And we have 8, and we have 10. For some reason, this equation often confuses students because there's no number in front of the x, but that's a 1. All right, so now it says to graph the equation. All right, and so if we look here, we simply need 2 points. So if we wanted to, we could go 4, 4. And we could also go 8, 8. All righty. And there is our line. And let's see if we were successful. We were. Awesome possum. All right. Now this time it's y equals 3x. So instead of them being the same, y needs to be 3 times as big. Although 3 times 0 is 0. So that one's going to be the same. 1 times 3 is 3, 2 times 3 is 6, 3 times 3 is 9. So again, if we were going to plot those points, we just need 2 points to graph a line. 0, 0, how about 1, 3? There is our line, and let's submit it. All right, let's jump up to the next level and see what they have for us there. All right, 3/4 of x, so we need to multiply it by 3/4. Well, again, 3/4 of 0 is 0. If it is a proportional relationship, it will always have 0, 0 as one of the ordered pairs. All right, what is 3/4 of 20? Well, 3 times 20 is 60, divided by 4 is 15. Or if we wanted to, yeah, that's the best way to do it, right? Well, we could divide 20 by 4 and get 5, and then to go 3 times 5 is 15. All right, 3/4 of 40, I hope you could quickly know that that is equal to 30. All right, so again, we need 2 points. 0, 0, how about we do 40 and 30? 40 and 30, awesome possum. There it is. 2/5 of x. Again, we need to take the number, multiply it by 2, and then divide it by 5. Or we can divide it by 5 and then multiply it by 2. But you will always have 0, 0 as one of your ordered pairs in a proportion relationship. All right, so if we do 2 times 25, we would get 50. And 50 divided by 5 would be 10. Or if we did 25 divided by 5, that would be 5, and 5 times 2 is 10. Either way, you get 10 as your answer. And of course, for 50, it's going to be 20, right? 2/5 of 50 is going to be 20. And again, if we were to graph those, all right, we can always graph 0, 0 as one of our choices in a proportional relationship. And let's go 25, 10 as our other one. Isn't this so much fun? All right, let's try skipping up to the next level and see what they have for us there. Ooh, we're in the challenge zone. Isn't this exciting? And then it's just more of the same. All right, 2/3 of x. So again, we're going to take x, multiply it by 2, and then divide by 3. Or take x, divide it by 3, and then multiply it by 2. But as I have said on previous occasions, 0, 0 is always one of your choices because 0 times anything is 0. All right, so 2 times 15 would be 30. Divided by 3 is 10. Or if we did 15 divided by 3, we would get 5 times 2 is 10. All right, again, when we have 30, that's an easy one. We know we're going to get 20. All right, 1/3 of 45 is 15, so this one's going to be 30. And by the way, I wasn't pointing it out, but as you can see, 0, 15, 30, 45, this one's going up by 15s. This one goes up by 10s. That is a sign of a proportional relationship. All right, so we have 0, 0, and then I'm going to go 15, 10, and Shazam, there we go. And look at that. We're back to our original one, and now we're in the challenge zone, which means I think it's time to move on to our next skill, K9. Graph a proportional relationship using slope. All right, it says Neil measures the lengths of some objects in both yards and feet. He finds that the number of feet is always 3 times more than the number of yards because there are 3 feet in a yard. All right, graph this proportional relationship. All right, remember what I said. In a proportional relationship, you can always include 0, 0. 1 yard is going to be 3 feet, right? 2 yards would be 6 feet. 3 yards would be 9 feet. The number of feet should always be 3 times the number of yards. And there we go. All right, but what did I do wrong? I made a mistake. Let's see here. Let's try this again. All right, Stacy is throwing a pool party to kick off the summer. Her pool is empty, so she starts filling it with water from the garden hose. The pool is filling up at a rate of 10 gallons per minute. 10 gallons per minute. Let's see if I can do this one without making a mistake. 0, 0. So 1 minute is 10 gallons. 1 minute is 10 gallons. All righty. Okay, now we're on a roll. Ezra is finding the perimeter of different sized rectangular pentagons. He finds that the perimeter is always 5 times longer than the side length. The perimeter is 5 times the side length, right? So 1 would be 5, correct? 2 is going to be 10, right? And notice it does go through 0, 0, even though that wasn't one of them that I chose this time. All right, let's skip up to the next level. All right, a witch brewed a magical invisibility potion. Oh, I want some. For every millimeter of potion the witch drinks, she is invisible for 35 minutes. So 1 is 35. So I'm going to go ahead because I don't have a lot of space here. 0, 0 will always work, right? 0 millimeters will give us 0 invisibility. 1 will give us 35, just like that. All right. By the way, they have been giving us the unit rates. When they give it for 1, that is the unit rate. So the unit rate for this one would be 35 minutes per 35 minutes of invisibility per 1 milliliter. All right, let me submit this and let's jump up to the next difficulty level. All right, Dalton is overjoyed. He graduated from college, but now he has to start paying back his student loans. He pays $50 per month. All right, that's our unit rate, right? So 1 is 50. 2 would be 100. Notice that's not going to be on the graph. So again, 0 months, $0. 1 month, $50. That's our only option there. The rest would not fit on the graph. All right, can we skip to the challenge zone? No, we cannot. Let's try again. Excellent. Now we are in the challenge zone. Kara wants to convert the duration of several flights from hours to minutes. She uses a website to do the math. She finds that the number of minutes is always 60 times more than the number of hours, right? 60 minutes in an hour, correct? So again, 0 hours is 0 minutes. 1 hour would be 60 minutes, right? 2 hours would be 120, which would not fit. I wish they made these graphs a little bit bigger so we can get more points on them. All right, I think we've got this one down. Just a reminder, when they tell you how much per hour, per minute, per anything, that's the unit rate. So I'm not going to do this problem, but if the studio charges $100 for each hour, $100 would be the unit rate. And that also would be the slope of the line. In fact, let me just do that real quick because I haven't even really been talking about slope, right? From there, 0, 0 always works, and then it's 100. Do you see that it goes up 100 and over 1? So the slope is the same as the unit rate. All right, congratulations to me. Let's go on to skill K10. Skill K10. All right, interpret graphs of proportional relationships. Okay, what does it have for us here? Jack's space shuttle crew accidentally left him behind on a mysterious planet. Well, that really stinks for Jack. He soon realizes his body is aging much faster. Wow, that's even worse. The graph shows the proportional relationship between the number of weeks Jack spends and the number of years he ages. So in 3 weeks, he ages 9 years. This is worse than dog years, right? Dog years? Oh my goodness. 3 weeks, 9 years. What does that point represent? After 9 weeks on the planet, his body has aged 3 years? No. After 3 weeks, take a look. 3 weeks, right? 9 years. 3 weeks, 9 years. Okay, next question, I think. Garrett loves to bake blueberry muffins for his friends and family. Aren't they lucky? I want to be Garrett's friend or family. The graph shows the proportional relationship between the volume of flour he uses in cups and the number of muffins he bakes. All right, so down here is cups. So 2 cups, because that's the X value, goes with 10 muffins. All right, 2 cups to 10 muffins. 2 cups of flour, he can bake 10 muffins. By the way, what would the unit rate for this one be? It would be 5, right? 5 muffins per cup. Do you see how 1 goes with 5? And that would also be the slope of the line. Up 5 over 1. Up 5 over 1. Let's see if they can make this any more challenging for us, because I don't know about you, but I'm not feeling very challenged yet. Ernest is throwing a pool party to kick off the summer. Oh, I can't wait for summer. His pool is empty, so he starts filling it with water from a garden hose. Okay, so if we take a look here, this is minutes and this is gallons. So in 5 minutes, it has 50 gallons. So what's the unit rate, boys and girls? What's the unit rate? We'll take a look over here. In 1 minute, it's 10 gallons. So the unit rate would be 10 gallons per minute. That would also be the slope of the line, up 10 and over 1. All right, so what does that point mean? That means it has 50 gallons of water after 5 minutes, 10 gallons per minute. I'm still not feeling very challenged. All right, let's see here. The graph shows a proportional relationship between the cleaning solution and the area of the carpet. So 2 quarts, do you see right here? 2 quarts goes up to 20 square yards. 2 quarts for 20 square yards. So what's the unit rate? There it is. It's 10 again, right? There it is. 10 square yards per 1. But they asked us 2 quarts for 20 square yards. They better get us into the challenge zone. No, let me try again. Challenge zone. Here we go. Okay, is it any more challenging? Graph shows proportional relationship, number of oranges and the amount of juice. All right, so here we go. We could see 10 oranges is 30 ounces, right? 20 is 60. All right, Kara has 90 ounces of juice. Here's 90 ounces. Do you see that? 90 ounces go over and go down 30. All right. By the way, the unit rate right there, we can't see what it would be for 1, can we? All right, but we know what it is for 10, right? 30 divided by 10 would be what? 3. Y divided by X, that's our constant of proportionality is 3. Our unit rate is 3. Our slope is 3. All righty. What about this one? If we take a look here, complete the statement. After drinking 7 millimeters of the potion. So if we go over here, here's 7 millimeters. It goes up to 70. Do you see that? There's the unit rate right there. 10 to 1, 20 to 2, 30 to 3. 7 goes with 70 minutes, right? The slope is 10, the unit rate is 10, the constant of proportionality is 10, and we are moving on to skill K11, which is write and solve equations for proportional relationships. All right, to prepare for the first day of the festival, Mitchell peels 5 potatoes in 10 minutes. All right, so we got to know what is our X and what is our Y. So X is the number of potatoes he peels, and Y is the time. So if you look, 5 potatoes, 10 minutes. Well, to find that constant of proportionality is Y divided by X. 10 divided by 5 is 2. Do you see how the number of minutes is twice as many as the number of potatoes? It takes him 2 minutes for every potato. Y is equal to 2x. All right. So how long would it take him to peel 9 potatoes? Well, 9 times 2 is 18, right? 2 minutes for every potato. All right, 18 minutes is what we would get. How many can he peel in 20 minutes? All right, so now they're giving us the minutes. So they're giving us y and asking for x. So when you're going from y to x, you divide by 2, right? Every potato takes 2 minutes. 10 times 2 is 20. All right. If Erica runs 1 lap, she raises $6. So X is the number of laps. Y is the amount of money she makes. So it's Y equals 6X, right? Every lap, $6. 1 lap, $6. 2 laps, $12. 3 laps, $18, right? So if she runs 2 laps, it's just what we said, right? 6 times 2 is not 2, excuse me. 6 times 2, I did not mean to put that, is 12. That's what I meant to put. 6 times 2 is 12. All right, if she needs to raise $18, again, dollars is the Y, so then we divide by 6 instead of multiplying by 6. 18 divided by 6 is 3. 6 times 3 is 18. 18 divided by 3 is 6. All right, what do they have for us next? Okay, the pool has 30 gallons of water after 1 minute. Okay, so if 1 minute gives us 30 gallons, Y is the number of gallons. You're going to multiply it by 30, right? 1 times 30 would be 30. So there we go. 2 minutes would be 60. 3 minutes would be 90, and so on. So if it has 60 gallons of water, that's what we just said, right? 30 times 2 is 60. All right, after 3 minutes, well, what's 3 times 30? It's 90. Okay, how about we skip up to the challenge zone, and then we're going to be done. All right, $39.80, she can buy 20 oatmeal cookies. All right, so Y is the cost, and X is the number of cookies. Are you with me? So write an equation. So we want to know what is that constant of proportionality. 20 cookies cost $39.80. So if I want to know the cost per cookie, that's my unit rate. I'm going to have to divide. All right, $39.80 divided by 20. Well, let's see. 38 divided by 2 would be 19, right? And a $1.80, that would be 19.19. Right? Or maybe you want to go ahead and get out a calculator and do 39.80 divided by 20 if your other math skills are not so great. Let me see here if I put this into my handy dandy calculator. Here we go. I'm going to go $39.80. And I'm going to divide that by 20 because Y divided by X, right? Y divided by X, and I get $1.99, right? $1.99 per cookie. All right, remember how I said it was 18 plus 19. There we go. $1.99 per cookie. Of course, if we think about it, if it was $2 per cookie, it would have been $4, right? So this should have been easy mental math, Mr. Reeves. Shame on you. All right, Y equals, what did I do wrong? What did I do wrong? 199. Did I forget the X? Oh, what? I put 199X. Did I? No, I just put 199. I forgot the X. Shame on me. Okay, how much do 40 cookies? Well, 40 times $1.99. Okay, well, if it was $2 a cookie, it would be $80, right? So we got to take off 40 cents. So 70, it would be 79.60. Let's see if I can get this one right. Yeah, there, that makes up for it. I didn't even use a calculator. How many cookies can she buy for $99.50? Well, think about it. If they were $2 each, right? 50 cookies would be $100, but it's 50 cents less. 50 cookies. All right, skip up to the next level. I'm so ashamed. I made 2 mistakes. 2 mistakes in this video. All right, Alec Day will never forgive me. All right, to get 10.1 ounces of water in his bottle, it takes him 101 seconds. Ooh, I'm liking this. 10.1, 101 seconds. All right, so the time is Y. All right, and the ounces is X. So we want to do Y divided by X to get that value of K, right? So 101 divided by 10.1, is that going to be 10 when we divide that? 101 divided by 10, we get 10.1. But I better put that X on there, huh? I better put that X on there. I'm going to get it wrong like I did last time. So how long does it take him to get 10.6 ounces of water, right? Well, the number of seconds is 10 times, right? The number of seconds is Y. All right, so it's going to have to be that times 10, right? It's going to take him 106 seconds because Y is always 10 times bigger than X. So the ounces is X, right? The ounces is X. You multiply 10.6 times 10. It simply moves that decimal over 1. We get 106 seconds. All right. And how much water does he get in 112 seconds? Well, now they're giving us the Y, all right, and they want the X, so we're going to divide by 10, and we get 11.2 because when you divide by 10, you move the decimal one place over the other way. Look at that. Despite my mistakes, I am extraordinary. Okay, and I did all that in 6 minutes and 14 seconds. All right, I hope you were able to overcome Mr. Reeves' horrible errors and that you can get even better than me because you are even more extraordinary. Have a great day, everybody. Until next time, bye.